Okay, so this example here is the hardest type of spherical geometry question you're going to get, and it's where you're asked to find the distance between two places. So here it's Kalgoorlie and Tamworth, and they're both on the same latitude, 31 degrees, but different longitudes. Okay, so what that means is here's Kalgoorlie on the diagram and Tamworth, and you'll notice now that they're not actually on a great circle around the globe, they're on a small circle. So the radius is no longer going to be 6,400 kilometers. So the first task is going to be to work out what the new radius of the small circle is in order to find out eventually the arc length of the arc I'm shading in right there. So first of all, we need to look at the degrees in the question. So it says 31 degrees. So that means that from the center there down to there is 31. Okay, I'll just zoom in a bit there. 31 degrees. And that means by Z rule, also we can say the same here, 31 degrees. Now, we also have this hypotenuse here, because that's the same as the radius from the center of the Earth to the outside, which is always 6,400. So if we draw our triangle on the right here, we've got 6,400 Ks and the other two sides of the triangle, and it's a right angled triangle obviously, and the radius that we're trying to find of the small circle is, we'll mark with R. Alright, so that's this bottom bit here. Okay, the radius is obviously the same, both red bits there. So as we've got adjacent to the angle and hypotenuse, we're going to use cos. So we're going to do 6,400 times by cos 31 to get the new radius of the small circle where they are both aligned. So just quickly type that one in. 6,400 times cos brackets 31 degrees. What have I done there? Okay, press Control Enter to get the approximate. Okay, so it's 5485.87. 5485.87. Okay, now we've got the radius now of this small circle. So going right around the Earth. Okay, and Kalgoorlie and Tamworth are obviously along this line. So now our goal is going to be to find out the arc length from K Kalgoorlie to Tamworth, alright, this arc length here. Okay, so if I just go back up to the diagram and show you again. So I'm going to rub out all of these to make it a bit clearer. This is 5,485.87. And now we're trying to find out the arc length here. Okay, on the outside. So what we need to do is identify this angle first of all. So I'll just highlight the angle for you there. So we need to find out this angle from the question. And if we go up to look at the latitudes and longitudes, you can see that the change, if we work out the difference, is 151 minus 122 gives us a change of 29 degrees. So that's the angle of the arc length. So if we go down to this diagram, you can see that now. We've just drawn it flat for ourselves to make it simpler. And so you go back to your standard equation for finding out an arc length, which is the circumference, which is 2 times pi times r, times by the fraction of the angle over 360. Okay, and that's to find out the length. So if we substitute in our known values here, we've got 2 times pi times 5,485.87, and that's going to be timesing by 29 over 360. And if we type that in a calculator, we should get our answer for the distance. So 2 times pi times the 5,485.87 times, and then press Control divide 29 over 360. And press Control Enter. And we have 2776.65. 2776.65. And that is obviously in kilometers.